Hi, this is Jeff Heaton. This is the next video in my series on Kaggle competitions. These are designed that you can watch them in any order. However, you might want to look at some of the other videos in this series. If you enjoy this topic and would like to see more from me, go ahead and click the subscribe button and click the little bell so that you're actually notified every time that I create a new video. This video will get a little more technical on my Kaggle utilities. So there's a link to these utilities on GitHub in the description to this video. These are designed not so much as just a Python package that you'll just pip import. This is meant more just as a starting point for you as you are going after your own Kaggle competitions. So you can see the diagram here that is right in the README file for GitHub. This is a process flow. This is how you take data from the raw Kaggle files, which are processed by these feature engineers, your features and extended features, and they flow straight through to where you have a Kaggle output. So let's just talk about this process flow, and then we'll get a little bit into the technology behind these. So if you look in the Python files that I have for this, you'll see that there are several files that start with data. These are features. Features are basically transformations that you do on the raw Kaggle data set. So these Python source files that you have here, you will create your own features, and you will also be putting in features from other competitors. These red color boxes are ones that you are basically taking in from other competitors as the competition goes on, because people will post features, and as they post features, you'll see your score drop because everybody starts to incorporate those. Now, some people get very mad about this when it happens late in the competition, so you can get mad and get beat, or you can incorporate their technology into your own, which is what I suggest for obvious reasons. So what'll happen is some of these feature transformations that you write and that others write, they will sometimes take hours. If you try to just keep creating this monolithic Python script that processes your entire submission, you're going to spend all your time on data processing because you'll have to rerun that darn thing every single time that you change. This is one of the main things that my utilities are for. They let you slowly piece together these and only modify what's changing in your pipeline. This saves tons and tons of time. Now, if you've got tons of money for AWS compute time, then just go ahead and run a monolithic file that does everything. Now, when you see people post solutions to Kaggle, usually they give you a monolithic solution. You just run this one big file or several files, it cranks, and then it spits out the result. Most likely they were doing something split up like this, and then when they wanted to post their solution, just kind of aggregated everything together into just one straight through set. Kaggle data files, you get a train and you get a test. This pipeline is built on keeping that together throughout the whole process. So the data file, we'll look at some of those in subsequent videos. These data processors for your features, for extended features, they work the same. They are going to take the Kaggle test and train, and they are basically going to run it through the transformation to generate the new features and generate these output files. You'll see those when I take you through the directory structure, but they're PKL files. They could just as easily be CSV. And by the way, these can output CSV. Everything is designed to take either a pickle file or a CSV file. Pickle files are binary in Python. And I have found you can lose some precision when you output something to CSV, parse it back in from CSV back to binary. So I tend to keep things in pickle straight throughout, but they're essentially like CSV files. Sometimes I will export to a CSV file just so I can go look at it real quickly. So the point is, you have all these features. I will tend to create more and more of these. I'll tend to call those like data-jth1, jth2. That's my initials, by the way. When other people put in features that I'm interested in, I basically put those in there too. They all generate these data XXX, where XXX is the name of the feature set. So now you've got all of these. So if I have 10 different feature files that I'm dealing with, and I only change this top group, I don't have to regenerate the entire thing. I've got all these data files that have been generated. You need a complete set of these features into one joined data set for the actual training. That becomes your feature vector. That's essentially the columns of all of your engineered features. And you need it for the train and the test, because if you're generating features to train off of, you need it in the test set that Kaggle's going to evaluate you on. So you'll see the joiner Python file. The joiner Python file is used to take all those feature sets and join them together. I also provide configuration so that you can turn off some of the features, and it does some other basic analysis. When we get into the joiner, you'll see exactly what that means. So then you end up with train joined and test joined. That is essentially all of these concatenated together. Again, that just saves you the big monolithic approach of having maybe 100 features that you're generating and having to rerun the whole thing every single time just to create your complete feature vector. You need to run models on these. So that's the next step in the process flow. Models are things like support vector machine, deep learning, all the XGBoost, all these very popular model types that can be used with Kaggle. Now you can sometimes have several versions of these, and you'll see how to do that in my source file, because you may not want to send the same feature vector to every single different model type, because support vector machines can handle very, very sparse data where others don't handle it as well. For the simple case, you'll just keep this, you'll be sending the same feature vector to all your different models. And I have it this way too. You will be training your own models, and you will see that as the Kaggle competition goes on, people will post models. People will post models sometimes that will get better scores than you. But guess what? If you ensemble those models with yours, usually that'll help your score. So people get very, very mad about that as well. People posting very advanced models late in the Kaggle competition. Like I said before, you can either get mad about that and get beat, or you can incorporate that into your solution. So when you run this, it is going to basically generate a directory. These are directories. Now the ensembler. Ensemble is absolutely critical to Kaggle competitions. It is one of the core pillars of Kaggle. Perhaps ensembling and feature engineering basically augment each other, and models that are not as strong in certain areas will be hopefully augmented by models in the other. Usually if you combine two models together, the end resulting score will be higher than both of those models put in. This gives you another model directory. This is the same format as these, so you could actually ensemble and ensemble together. Fancy diagrams are neat and all, but let's look at the code. The very first thing that you want to do is deal with this config file. So config file, basically in Kaggle, usually one of the columns is an ID that identifies it. So you just need to know what the train and test IDs are. Usually those are going to be the same. The goal is to minimize the error. That depends on the error type that you have. Here we are doing regression. We're predicting a number. You can also do single class classification. My utilities do not currently support multi-class classifications, and why? I simply haven't applied this full set of utilities to something that would require multi-class classification. And I did do the auto group challenge, and that required it, but I've since made improvements to this, so I'll probably take on a Kaggle at some point soon and add in multi-class classification. If anybody wants to contribute code for that, that's obviously great. Here is where I put in my 3 paths. The reason I have 3 paths to where I am saving this is it depends on the operating system I'm running. I tend to use a number of different computers in this process. I mostly work on Macs, but if I am in a Linux environment, that usually means that I am in AWS, and I've submitted something to an EC2 instance for running. I'll probably do a video on that as well, so lots of videos, definitely subscribe. This is a fairly big topic. I mean, you can do the very simple intro to Kaggle, but if you want to get into the higher percentiles, it's definitely, you need to use more advanced techniques. These are 2 of the data generators right here. The data JTH1, this is an example of feature engineering that I was doing for the Mercedes challenge. So you can see here, I am essentially, this is all pandas code, and then at the very, very end, I am basically I'm using a class in Python that I created that basically runs, generates it, and also prints out a report of what it did at the very end. The output from this is going to be a pickle file. We'll get into, I'll do an entire video just on feature engineering and how to build one of these files from scratch, because it's a topic completely unto its own. This is the red colored one that basically I took from somebody else. So if you notice, we're reading in the two key Kaggle files that they give us, and it is processing all of them. This is code that somebody else created. And then you'll see at the very, very end, I just dumped this to CSVs. So this shows you basically how you take existing code that somebody else has created. You just need to dump it to the train and test CSV, and then it flows into the rest of my framework just fine. It takes scored train and test files from Kaggle. The joiner. This is very important. So you're defining a profile. Very bottom, you run it by running the profile. Modify the code at the beginning, or at the end, just to run it, and the code at the beginning to specify the profile. This tells you the name, so this is profile 1. The reason is you might want multiple feature vectors. You might not want all your models to be using exactly the same feature vector. Often you will have just one feature vector, and then you just have one profile. But this gives you a way to generate those additional feature vectors if you actually need them. Are the sources, so JTH1 and cur1, those are those two files generated from data. Balancing, be very careful with that. I will talk about balancing when I deal with the it lets you put in column names that you would simply like to drop out. It simply tells you the files that it processed, and it's done. The train Python files are used to train. Here I have scikit-learn, xgboost, also tune xgboost. I'll do an entire video on tuning, because that's how you tune the hyperparameters. And that can definitely give you a little bit of a gain as you create these models. The train scikit-learn one is pretty cool. I built it so that you can essentially train any number of these scikit-learn based models, and you can build up a whole list of these and build bigger and bigger ensembles based on that, and that can definitely give you some increased advantage in this. I generated several of those, so let's take a look at those now. That I'm using as a data directory. And that's what you configure in the config file. Test and train, those are the files that came literally right from Kaggle. The joined that the joiner created from so first I generated my data files. So those are all my data files from the two different ones that I had. So I'm generating JTH1 test and train. Now I also outputted the CSVs so that if you want to look at them and see what the actual engineered features look like, and also the pickle files. Joining them together gives you test and train joined. So we're keeping the test and train just throughout this whole process flow. When I train the models, you'll notice here's AdaBoost. I trained XGBoost. I trained XGBoost and AdaBoost just for this little example here. I'm not going to actually run them because they take more time than I want this video to last for. But if you go into one of them, like if you go into XGBoost, you'll see basically 0p, that means 0 point. So the score was 0.5767. Ran it twice and got the same score at different times. And if you look into here, this is what it generates. These are the out-of-sample predictions for the entire training set. That is very useful for ensembling. So if you can generate out-of-sample predictions, and I'll show you what that looks like. This is just the ID and the expected value, so that comes from Kaggle, and then the predicted. So you can see there's definitely some difference there, closer there, and so on. So we generate this for every single model so that we can evaluate that particular model, and we also use this for ensembling. But this is all you need, these files, so that you can actually ensemble them together. Now the submit file, that is what you would actually send into Kaggle. So if I went into Kaggle and submitted this file, that would be that individual model submitted. And I also zip it up just so that we can send that. Some of these get kind of big, and you can send the zip file to Kaggle. This txt file is just a status file that I create. This is just a dump of useful information. I keep the cross-validated scores so that we know how it performed on individual folds. If you see one fold varying considerably, that tells you have some outliers rolling around in there, among other things. These are the hyperparameters that went into XGBoost, and we'll tune those. We'll see how we can tune those for various model types. This is not used by the program. This is purely for your own reference, and this is how I remember what parameters I actually ran on these. Let's see how to ensemble it real quickly. I put together a brief script that will ensemble the AdaBoost and XGBoost. So we're going to use the one down here. So we're going to use the Lasso Lars cross-validator. There's several different ones that you can use. Lasso is good because it's fairly aggressive and will remove models from the mix that are not particularly performing, but you can use really any of these that I've experimented with. These are just different ways of ensembling it together. Now I'll have a whole video just on how to use the ensemblers, and definitely subscribe to know when that is coming. The code to do the ensembling, don't worry about that. You don't really need to modify it. The folder names of what you are trying to ensemble. Now this can get long. You can put 10, 20 models in here and ensemble them all together. Let's go ahead and run the ensembler. There is a whole lot of information that it gave you there. Results. Notice these numbers. This is fascinating. You totally want to pay attention to this. These are the two models that you created. I intentionally created a fairly bad model here based on AdaBoost. Nothing to do with AdaBoost. It's just I didn't set that one up particularly well. And you see these numbers. So those are the ratios that it's putting these into the final blend. So you can see it really liked XGBoost a whole lot better than AdaBoost. But yet AdaBoost was not completely worthless, so it did not throw it out altogether, or that would be a 0.0. These numbers should sum to 1, and that just shows you the percentage that these are coming together. The blend is given here. It gives an estimate of what it thinks the error of that blend would be, that you'll get a different value in Kaggle when you submit it, but it'll probably be somewhat close to that. If you wanted to submit the results from that blend, you would go into here and actually send this the actual submit. That's a general overview of how to make use of these utilities that I make available. The next videos are going to describe each of these one by one. Subscribe to this channel and you'll see all about that. Thank you very much.